In the summer of 1877, the Pacific Ocean released a surge of heat so vast and so violent that it rewired the weather of the entire planet simultaneously. What followed was not a regional weather event or a temporary disruption to a single harvest season. What followed was a synchronized global catastrophe on a scale that history has never been able to fully absorb. Monsoons vanished over India. Rivers ran dry across northern China. The Brazilian sertão baked and cracked under relentless heat. Harvests failed across 3 continents at the same moment, under the same invisible climate mechanism, as if the atmosphere itself had turned against the people depending on it. By the time it was over, more than 50 million human beings had died, most of them from starvation and the epidemics that followed in its wake. That death toll represented 3 to 4% of the entire population of the planet at the time. If a comparable fraction of today's global population were to die, the number would exceed 250 million people. The cause of that catastrophe was a super El Niño. Now, nearly a century and a half later, climate scientists are warning that an event with the potential to rival or exceed what happened in 1877 is building in the Pacific Ocean right now. The Daily Express and a growing number of climate and international affairs publications have begun drawing the comparison explicitly, not to cause panic, but because the scientific data now demands that the parallel be examined honestly. The 2026 El Niño is not simply a warm year in the Pacific. Multiple global forecasting systems spanning the United States, Europe, Japan, and Australia are projecting that the event now taking shape could become one of the most powerful El Niño episodes in recorded history. NOAA is currently giving a 1 in 4 chance that this event reaches very strong intensity. University of Albany professor of atmospheric science Paul Roundy has described the emerging pattern as potentially the biggest El Niño since the 1870s. The World Meteorological Organization has stated that there is high confidence in the onset of El Niño, followed by further intensification in the months that follow. These are not fringe voices. These are the central institutions of global climate science. They are all pointing in the same direction. To understand why the 1877 comparison matters so deeply, it is necessary to understand what actually happened during that event and why it killed so many people. The mechanics of the 1877 El Niño were in some ways similar to what is now developing, but the world in which they operated was different in every political and economic respect. The Pacific warming that triggered the event followed years of drought that had already begun spreading across the tropics and subtropics from 1875 onward. When the full strength of the El Niño developed in 1877, it did not operate alone. Alongside it, the Indian Ocean Dipole shifted into a positive phase, amplifying and directing the drought impacts across South Asia. A pattern of unprecedented North Atlantic warming added further disruption to the atmospheric circulation of the Northern Hemisphere. The combination of these 3 simultaneous oceanic forcings produced a weather system of extraordinary power, one that did not simply cause a bad monsoon season in India or a poor harvest in China. It caused both simultaneously for multiple consecutive years, removing the ability of any regional food system to absorb a single failure and recover before the next one arrived. In India, the drought devastated the Deccan Plateau and the Madras Presidency in 1877 and continued through 1878. Historians who have studied the event, most prominently Mike Davis in his landmark 2001 work examining the intersection of El Niño and Victorian imperialism, describe the scale of the suffering in terms that are almost impossible to comprehend. The Indian population was already under the strain of a colonial economic system that had dismantled indigenous food security mechanisms, forced the conversion of subsistence farmland to export monocultures, and systematically drained the subcontinent of the agricultural surplus that might otherwise have buffered communities against crop failure. When the monsoon failed, there was nothing to fall back on. The British Viceroy at the time, Lord Lytton, was ideologically committed to the principles of laissez-faire economics and refused to divert government resources toward meaningful famine relief, instead holding lavish celebrations for Queen Victoria's investiture as Empress of India while millions starved. Relief camps were established on terms so punishing that many chose death over the humiliation of attending them. Contemporary observers described the famine as one of the most preventable catastrophes in history, caused not solely by the weather, but by the political choices layered on top of it. In northern China, the Yellow River region experienced a drought so severe that rivers dried and fields turned to dust, followed by catastrophic floods when rains finally returned, wiping out what remained of the population's ability to sustain itself. In northeastern Brazil, the Sertão, the semi-arid interior region, experienced the kind of multi-year drought that its social structure was wholly unprepared to survive. Across sub-Saharan Africa, harvests failed across multiple regions simultaneously. The 1877-78 El Niño produced not one famine in one country, but a cascade of simultaneous food system collapses across 4 continents, all driven by the same climate forcing operating through different regional teleconnections. Researchers who have studied the event closely have written that it was arguably the worst environmental disaster ever to befall humanity, and that conclusion is difficult to dispute. No other single climate event in recorded history has killed a comparable number of people in a comparable time frame. What makes the 2026 comparison both compelling and genuinely alarming is the way the current global conditions echo the structure of 1877, while adding dimensions that did not exist in the Victorian era. In 1877, the El Niño struck a world in which food systems were fragile, political will was absent, and the poorest populations had been deliberately stripped of their resilience by colonial economic policies. In 2026, the El Niño is arriving into a world where food systems are under pressure from a different but equally serious set of stressors. Global grain reserves are already being drawn down. Crop yields for staple commodities, including maize and wheat, are declining in several major producing regions due to rising temperatures and prolonged heat waves that have nothing to do with the El Niño itself. The conflict in Ukraine has disrupted wheat and fertilizer supply chains. Ocean warming has already begun affecting fish populations that support the livelihoods and caloric intake of hundreds of millions of people in the developing world. A very recent joint United Nations warning highlighted that extreme heat and climate stress are pushing global food systems toward critical thresholds even before the additional disruption of a strong El Niño has been factored in. Climate analyst Lee Mante, writing for the Observer Research Foundation in May 2026, was specific about the likely crop impacts. A strong El Niño is projected to drive drought conditions that reduce rice, wheat, and maize production across Asia and Australia, while wet conditions in the Americas may boost soybean output. The asymmetry is deeply significant. The populations most dependent on rice and wheat are concentrated in South Asia and East Asia, regions where hundreds of millions of people exist on narrow caloric margins, and where even a modest reduction in domestic grain production can trigger price spikes that move essential food beyond the reach of the poor. The Food and Agriculture Organization has repeatedly highlighted that El Niño-driven climate hazards pose significant risks to agriculture and rural livelihoods in exactly these regions. What the historical record from 1877 shows, and what the 2026 forecasts are beginning to make visible, is that the global food system has a structural vulnerability to simultaneous multi-regional crop failures that it has never fully addressed. It is also worth understanding where the 2026 El Niño sits in relation to the three major super El Niños that the modern instrumental record has captured. The 1982 to 83 event was the first to be monitored with anything approaching the density of ocean buoys and satellite data that scientists now rely on, and it still managed to develop almost undetected until it was well underway, catching meteorologists and governments off guard. It caused severe droughts across Australia, India, and sub-Saharan Africa, while driving catastrophic flooding along the Pacific coast of South America. The 1997 to 98 event was, at the time of its occurrence, the most intense ever recorded, producing the first global coral bleaching event in history, devastating monsoon seasons across South Asia, and long-term soil moisture depletion across the Australian continent that affected agricultural productivity for years after the Pacific temperatures had returned to normal. The 2015 to 16 event set a new global average surface temperature record for that calendar year, drove mass coral bleaching across the Pacific and Indian Oceans simultaneously, and pushed what scientists now call climate regime shifts in several regional systems, lasting changes that did not simply reverse when the El Niño ended. Each of those three events was considered extraordinary at the time of its occurrence. The developing 2026 event is being discussed in the same terms by the same institutions that monitored its predecessors, and the background global temperature against which it is developing is significantly warmer than any of the three. The role of the Indian Ocean Dipole, which is sometimes described as El Niño's little brother, deserves particular attention in any honest assessment of the 2026 risk picture. During the 1877 event, the Indian Ocean Dipole shifted strongly into its positive phase at the same time as the Pacific El Niño was developing, creating a reinforcing combination that amplified the drought impacts across South Asia and East Africa to a degree that neither system would have produced alone. Climate scientists monitoring the current developing pattern are watching the Indian Ocean Dipole carefully, because if it shifts into a strong positive phase alongside the Pacific El Niño in the second half of 2026, the combination would recreate one of the key structural features of the 1877 catastrophe: a joint strong El Niño and strong positive Indian Ocean. Dipole is statistically unusual, but it has happened before, and the consequences of that combination for the monsoon systems of South Asia and the agricultural systems of the maritime continent are well documented in the historical record. The probability of that combination developing in 2026 is not yet clear, but the possibility is precisely what is driving the comparison to 1877 in scientific and policy circles. The specific mechanism that makes a super El Niño so much more dangerous than a moderate event lies in what climate scientists sometimes call the triple whammy. During a strong El Niño, it is not just the Pacific Ocean that shifts. The event influences the Indian Ocean Dipole and can interact with temperature anomalies in the Atlantic as well, creating a situation where multiple oceanic systems are simultaneously forcing the atmosphere in directions that compound rather than cancel each other. The result is a single trans-Pacific atmospheric circulation pattern that can lock drought onto linked regions simultaneously across multiple continents, not for a single season, but for extended periods that destroy the capacity of those regions to recover between crop cycles. The global food system, with its insurance frameworks, reserve policies, and trade models, is built on an assumption that simultaneous widespread crop failure across multiple major producing regions does not happen. The 1877 event proved that it can. The current forecasting data suggests that 2026 may be walking toward a moment that tests that assumption again. There is a dimension of the 1877 catastrophe that rarely receives the attention it deserves in modern discussions of El Niño risk, and that is the extraordinary speed with which the disaster compounded once the first crop failure registered. Populations living on narrow agricultural margins do not have the luxury of absorbing a single failed harvest and waiting for the next season. When the monsoon fails in India or the rains disappear from northern China, the consequences are not felt gradually over years. They are felt within months, as grain prices spike, as the poorest households exhaust their limited reserves, as animals die and the following year's planting capacity is destroyed along with the livestock that would have worked the fields. The 1877 famine moved with a speed that overwhelmed the administrative capacity of every government dealing with it, colonial or otherwise. It exposed the fundamental incompatibility between the timescale on which bureaucracies move and the timescale on which hunger kills. The lesson that climate risk analysts draw from this is not simply that El Niño is dangerous, but that the danger accelerates nonlinearly once a threshold of food system stress is crossed. The global food system in 2026 is entering the El Niño with that threshold closer than at any point since the 1870s. And that proximity is what gives the historical comparison its unsettling contemporary resonance. The warning for the United Kingdom, as the Daily Express and other outlets have begun to articulate, operates on two distinct timescales. The first is the near-term summer and autumn picture. El Niño's direct effects on UK weather are generally indirect and lagged compared to its impacts in the tropics in the southern hemisphere. However, strong El Niño events do alter the positioning and behavior of the Atlantic jet stream, which is the primary driver of UK weather patterns. The Met Office has noted that strong El Niño winters in Britain tend to bring a mild start followed by a cold and stormy end to the winter season, with elevated probability of deep, low-pressure systems tracking across the Atlantic toward the British Isles. Chatham House, one of the UK's most respected international affairs research institutions, published a report in May 2026 explicitly warning that the 2026 Super El Niño could expose gaps in UK preparedness, noting that Storm Babet, which caused significant flooding across the UK in 2023, coincided with the previous El Niño event of 2023 to 2024. A stronger event in 2026 raises the realistic probability of more severe storm sequences, with the kind of extended power cuts, flood damage, and infrastructure strain that the UK's aging drainage systems and electricity grid are poorly positioned to absorb. The second, and arguably more consequential timescale for UK households is the economic and food supply impact that typically arrives, not during the El Niño itself, but several months after the agricultural disruptions begin. The Office for National Statistics has estimated that it takes between 7 and 13 months for upstream food production cost changes to reach supermarket shelves in Britain. The El Niño's agricultural effects on rice, grain, and palm oil production in Asia and Australia are beginning to develop now in mid-2026. That means the food price consequences of those disruptions are likely to land on UK household budgets in the winter of 2026 and into spring 2027, arriving on top of fuel costs and other inflationary pressures that are already elevated. Two separate economic shocks, one from energy and one from global food supply disruption, converging on the same point in the calendar. The Committee on Climate Change's May 2026 adaptation report to the UK government identified heat, flooding, and drought as the three largest climate risks facing Britain and advised preparation for 2 degrees of global warming by 2050 under current policies, with a realistic probability of up to 4 degrees by 2100. The developing El Niño sits directly within that risk framework. The comparison to 1877 should not be taken as a straightforward prediction that 2026 will now produce anything close to the death toll of the Victorian catastrophe. The world has changed enormously in the intervening century and a half. modern early warning systems, international food aid mechanisms, satellite-based crop monitoring, and global logistics networks provide tools for responding to agricultural failures that simply did not exist in the 1870s. Vaccination programs and improved medical infrastructure mean that the epidemic diseases that compounded the mortality of the Victorian famines are less likely to kill at the same scale in most parts of the world today. International humanitarian organizations, including the FAO, WFP, and UNICEF, have developed anticipatory action frameworks that allow resources to be positioned in vulnerable regions before a crisis fully develops, rather than only after the worst has already occurred. These are real, but the structural parallel remains, and it is not reassuring on examination. In 1877, the deaths were not caused solely by the weather. They were caused by the interaction of extreme climate forcing with political systems that placed ideological commitments ahead of human life, with colonial economic structures that had stripped populations of their resilience, and with food systems that could not absorb simultaneous multi-regional failures. In 2026, the analogous vulnerabilities are different in character, but present in form. The global food system remains highly sensitive to simultaneous multi-regional crop failure. Political systems in multiple major countries are under strain, and in some cases, openly hostile to the international cooperation that effective humanitarian response requires. The poorest populations in the most El Niño-sensitive regions have seen their agricultural resilience eroded by decades of structural adjustment policies, land consolidation, and the relentless pressure of rising baseline temperatures. The warning is not that history will repeat itself identically. The warning is that the conditions that allowed 1877 to become a catastrophe, rather than simply a difficult year, have structural counterparts in 2026, and that recognizing them early, as the Daily Express and the scientific community are now doing, is the only basis on which a different outcome can be built. Professor Paul Roundy of the University of Albany, one of the leading atmospheric scientists studying the developing pattern, summarized the situation with the kind of measured precision that makes it more alarming, not less. He noted that ecosystems have evolved with El Niño for millions of years, and that some of these extreme events are part of natural renewal cycles. But he also stated clearly that the human impact, the social impact, and the impact on life in a world of over 8 billion people with a climate system already destabilized by decades of greenhouse gas emissions is a different matter entirely. The scale of what is building in the Pacific Ocean right now is not yet certain. The trajectory of the 2026 El Niño could still develop into a moderate rather than a historic event. But the probability that it does not, the probability that what is forming in the equatorial Pacific becomes something the world has not seen since 1877 is high enough that the comparison deserves to be taken seriously rather than dismissed as sensationalism. For the people of the United Kingdom, the immediate experience of a super El Niño winter will be defined by storms, flooding risk, and food price pressure rather than the famines that killed millions in the colonial tropics. But those two realities are not separate. They're connected by the same global system, and understanding that connection is the starting point for responding to it with the seriousness it demands. The food on British supermarket shelves comes from the same global agricultural system that is most vulnerable to what El Niño does to harvests in South Asia, Southeast Asia, Australia, and Sub-Saharan Africa. The storms that batter the UK coastline in a strong El Niño winter are driven by the same altered jet stream that redistributes rainfall away from the places that need it and toward places that cannot contain it. And the global political instability that tends to follow crop failures and food price spikes in vulnerable regions does not stop at any border. The 1877 catastrophe was framed at the time as a distant tragedy happening to people in distant lands. What the science of El Niño has since revealed is that it was never distant at all. It was always one connected system, and 2026 is asking whether the world has learned that lesson well enough to respond differently this time.